you're in space, you float around.
What are you singing, Bhargavi?
This is our project day song. Would you like to hear it?
Yes, why not?
Sure.
When you're in space, you float around. You can't run a race when your feet don't touch the ground. But when you're on a planet, there's a special force. It holds you down and it keeps the ship on course. It's gravity, an invisible friend. It makes you part of the planet, and so you can depend on gravity. It never goes away.
It's working all the time to get you through the day. When you're in space, you're a tiny thing. You're not connected, no one else can hear you sing. But when you're on a planet, there's a special force. It holds you down and keeps the ship on course. It's gravity, an invisible friend. It makes you part of the planet, and so you can depend on gravity. It never goes away.
It's working all the time to get you through the day. When you're in space, you sleep standing up. You float around the ship and you can drink from a cup. But when you're on a planet, there's a special force. It pulls you down and it keeps the ship on course.
It's gravity, an invisible friend. It makes you part of the planet, and so you can depend on gravity. It never goes away. It's working all the time to get you through the day.
Gravity, an invisible friend. It makes you part of planet, so you can depend on gravity. It never goes away. It's working all the time to get you through the day. Gravity, an invisible friend.
Thank you.
Nice song.
Thank you. Did you know Atish and Aditya are meeting at the pizzeria?
Is it?
Yeah.
Let's go see what's happening there.
The pizza was delicious, but I was wondering how quickly the pizza shape was being formed. It's magical.
It's not magic, Aditya. Gravity is helping him.
Oh, gravity? How is it possible?
Yes, my friend. Gravity is not only helping pizza to get its shape, it is also shaping the celestial objects.
Oh, is it? I'm curious to know. I only heard about the apple story. I'm eager to know more about it.
Greetings all. We all know what gravity is, the universal force of attraction acting between all matter. Let's see what Isaac Newton's theory says. Universal law of gravitation. Newton's universal law of gravitation states that every object in the universe attracts every other object with a force which is proportional to the product of their masses and are inversely proportional to the square of the distance between them. This publication of the theory is known as the first great unification, as it marked the unification of the previously described phenomena of the gravity on Earth. It is a part of classical mechanics and was formulated in Newton's work, the Principia, which was first published on 5th July 1687. If m1 and m2 are the masses of the two objects, r is the separation between them. The gravitational force Fg between them is given by Fg is equal to g m1 into m2 by r square, where g is the constant of the proportionality and is called the universal gravitational constant. The accepted value of g is 6.673 into 10 power minus 11 Newton meter square per kilogram square.
The law is universal in the sense that it is applicable to all bodies, whether they are big or small, whether they are celestial or terrestrial. So, As the mass of either of the object increases, the gravitational attraction between them also increases. Also, as per this inverse square law, Fg is inversely proportional to the square of r. Means, for example, that if r gets bigger by the factor 3, F becomes 1 by 9 times smaller.
I wonder whether the gravity concept was known before.
Claudius Ptolemy was a mathematician, astronomer, geographer, and astrologer who wrote about a dozen of scientific treatises. To facilitate astronomical calculations, Ptolemy tabulated all the data needed to compute the positions of the sun, moon, and the planets, the rising and setting of the stars, and the eclipses of the sun and moon, making it a very useful tool for astronomers and astrologers. Ptolemy placed the Earth at the center of his geocentric model.
Nicholas Copernicus was the Polish astronomer known as the father of modern astronomy. He was the first modern European scientist to propose that Earth and other planets revolve around the sun.
Galileo Galilei discovers the parabolic arc of projectiles through projects. According to the story, Galileo Galilei discovered through this experiment that the objects fell with the same acceleration, provide his prediction true. In 1589, Galileo Galilei describes a hydrostatic balance for measuring specific gravity.
Science needs imaginative and daring theorists who can soar high in the world of the almost impossible. Kepler belonged to this tribe. Science also needs accurate and observational data, which was by no means bound to the ground. Brahe's data did just this. But the merging of a theory and experiment was by no means straightforward or easy. So, Johannes Kepler is rightly acclaimed as the father of modern astronomy. But he could have not achieved this distinction without Brahe's observational data, which are unanimously considered most accurate and comprehensive in pre-telescopic astronomy.
Isaac Newton was an English mathematician, physicist, astronomer, theologian, and author. Newton formulated the laws of motion and universal gravitation that formed the dominant scientific viewpoint until it was suppressed by the theory of relativity. Newton used his mathematical description of gravity to derive Kepler's law of planetary motion.
Albert Einstein argued that gravity isn't a force at all. He described it as a curvature of time and space caused by mass and energy. According to Albert Einstein, gravity was a natural consequence of mass's influence of space.
Hi guys, now I'm going to show an experiment. With me, I have a feather and a stone. The mass of the feather and stone are different. Now I'm going to drop the feather and stone down simultaneously. So, if you have seen, the stone has fallen down first. Why not the feather? Now, we're going to try it again with a different stone and the same feather. The mass of the stone and feather are now equal. Again, if you have seen, the stone has fallen down first. Why do they fall at different rates?
Today, we are going to see the purpose of Galileo Galilei's experiment. Let us see. Galileo took two cannonballs of different weights but with similar levels of air resistance. He dropped both the spears from exactly the same height at exactly the same time. Although they had different masses, the cannonballs fell at a very similar rate. And last of all, the two balls hit the ground almost instantaneously. The difference in falling time due to air resistance was far less than the amount predicted by Aristotle's theory. This experiment was also conducted on the moon by David Scott with a feather and a hammer.
Now let's see what kind of experiment David Scott had conducted on the Apollo mission.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Proves that Mr. Galileo was correct in his findings.
So, David Scott had conducted an experiment on free fall. Free fall is the motion of an object in which the object is being affected only by the gravitational force. If an object is dropped from a certain height, the velocity will keep on changing second by second. As soon as the object is dropped, its velocity will be 0 meter per second. After 1 second, the velocity will be 9.8 meter per second. After 2 seconds, the velocity will be 19.6 meter per second. And after 3 seconds, the velocity will be 29.4 meter per second, and so on. So, on Earth, free fall accelerates objects at a uniform rate of 9.8 meter per second square.
Kepler's laws of planetary motion. The Kepler's laws describes the orbits of planets around the Sun. The laws modified the heliocentric theory of Nicolaus Copernicus, replacing circular orbits and epicircles with elliptical trajectories, and explaining how planetary velocities vary.
Kepler's first law of planetary motion. Each planet's orbit about the Sun is an ellipse. That is, the Sun's center is always located at one focus of the orbital ellipse. The planet follows the ellipse in its orbit, meaning that the planet to Sun distance is constantly changing as the planet goes around its orbit. The orbit of a planet is an ellipse with the Sun at one of the foci as shown below.
Kepler's second law, law of equal areas. Kepler's second law of planetary motion describes the speed of a planet traveling in an elliptical orbit around the Sun. It states that a line between the Sun and the planets sweeps equal areas in equal times. Thus, the speed of the planet increases as it nears the Sun and decreases as it recedes from the Sun.
Kepler's third law, law of harmonics. The squares of the orbital period of the planets are directly proportional to the cubes of the semi-major axis of their orbits. Kepler's third law implies that the period for a planet to orbit the Sun increases rapidly with the radius of its orbit. Newton used the law of Kepler to calculate the gravitational force of attraction.
I think by sitting at home, I've gained a lot of weight. What to do?
Why don't you go to the moon and measure your weight? You will feel happy.
Why should I go to the moon? How is it connected to my weight?
Do you want to know? Let us see what our friends have to say on this.
Mass and weight. Remember, it is important to remember that mass is different from weight. Mass always stays the same, while weight changes with changes in gravity. Difference between mass and weight. Mass is the quantity of matter in a body regardless of its volume or any force acting on it. Weight is the measurement of gravitational force acting on an object. Mass is always constant at any place and time. The weight of an object depends on the gravity of the place. The SI unit of mass is kilogram, kg. The SI unit of weight is Newton, N.
If m is the mass of the object and g is the acceleration due to gravity at that place, its weight w is calculated as weight is equal to mass into acceleration due to gravity. That is w equals to mg. For example, let us compare the weight of an object of 56 kg mass on Earth and Moon. On Earth, the mass is 56 kg and on the Moon also the mass is 56 kg. The weight on Earth is equal to mass into acceleration due to gravity on Earth, which is equal to 56 kg into 9.88 meter per second square, which is 548.8 Newton. And on Moon, the weight is equals to mass into acceleration due to gravity on Moon, which is 56 kg into 1.6 meter per second square, which is equal to 89.6 Newton.
Hi friends, my mass on Earth is 49 kg. My weight is 480 Newton. Now let me go to Mercury and check my weight. I'm on Mercury and my mass is still 49 kg, but my weight is 176 Newton. Now let me go to Venus and check my weight. I'm on Venus and my mass is still 49 kg, but my weight is 436 Newton.
Hi friends, I'm on Earth and my mass is 40 kg. My weight is 392 Newton. Now I'm on Moon and my mass is 40 kg and my weight is 64 Newton. Now I'm on Mars. My mass is 40 kg but my weight is 152 Newton.
Hi friends, my mass on Earth is 42 kg. My weight is 411 Newton. Now I am on Jupiter. My mass is 42 kg still, but my weight is 1092 Newton. Now I am on Saturn. My mass is 42 kg. My weight is 466 Newton.
Hi friends, my mass on Earth is 50 kg and my weight is 419 Newton. Now I am on Uranus. My mass is still 50 kg, but my weight is 535 Newton. Now I am on Neptune. My mass is still 50 kg, but my weight is 705 Newton.
Oh, now I understood why you were suggesting me to go to the moon.
Was Newton wrong about gravity? Let us understand it better.
Effects of gravity on Earth and solar system. Existence of solar system, galaxies and constellations. The gravity is what holds the planet in orbit around the sun and what keeps the satellites in orbit around their planets. Gravity creates stars and planets by pulling together the material from which they are made. Formation of tides. Tides are caused by the gravitational pull of the sun and moon on Earth. Although the sun and moon exert gravitational force on Earth, the moon's pull is stronger because the moon is much closer to Earth than the sun. When the sun, moon and Earth are all lined up, the sun's tidal force works with the moon's tidal force and cause very high tides.
Our sun is majorly a combination of gases and vapors. The gases present in the sun do not leave the celestial body because of gravity. Gravity holds the atmosphere on the Earth, otherwise it would dissipate into space. Gravity brings the rain back down after it evaporates into the atmosphere. The river flows downwards due to gravitational force.
Bhargavi, please switch on the TV. There's a special news telecast regarding the Columbia spacecraft disaster.
Oh, okay, let me switch it on.
Good morning and welcome to BVM Space Travel Live. This is Ovia here and today we're going to talk about the Columbia spacecraft disaster. On February 1, 2003, Space Shuttle Columbia broke up as it returned to Earth, killing the 7 astronauts on board. NASA is suspending space shuttle flights for more than 2 years to investigate the disaster. Now we have Mr. Kaushik, our reporter, to share a few facts about the disaster.
Hello.
Hello, Mr. Kaushik. I have a few doubts and questions about the Columbia spacecraft disaster. How did the spacecraft crash suddenly on its way back to the Earth?
The investigation board determined that a large piece of foam fell from the shuttle's external tank and breached the spacecraft wing. This problem with foam had been known for many years, and NASA came under intense scrutiny in the Congress and in the media for allowing the situation to come.
Thank you for the information, Kaushik. Who were the 7 astronauts who died during the mission?
The 7 astronauts who have died in the mission are Commander Rick Husband, Pilot William McCool, Payload Commander Michael Anderson, Mission Specialists Kalpana Chawla, David Brown and Laurel Clark, and Payload Specialist Ilan Raman. Columbia was the first space shuttle to fly in space. Its first flight took place in April 1981 and it successfully completed 27 missions before the disaster. On its 28th flight, Columbia left Earth for the last time on January 16, 2003. Columbia's final mission, known as STS-107, emphasized pure research.
That was very informative. And what are the experiments made by the astronauts?
The 7 astronauts had spent 24 hours a day doing science experiments in 2 shifts. They performed around 80 experiments in life sciences, material sciences, fluid physics and other matters before beginning their return to the Earth's surface.
Thank you very much for explaining this to us. We have a special interview live in the show, starring 2 astronauts, so make sure to keep watching. This is Obia BBM Space Travel Live signing off. We'll see you soon.
Hello, I am Siddhant. I am going to interview Mr. Manjunath. It's a pleasure to meet you.
Hi, it's a pleasure to meet you too.
Hello, this is R. Srakaran. I'm going to interview Miss Aishwarya. It's good to meet you.
Hi, it's good to meet you too. Thanks.
So, how does it feel during takeoff?
Nice question. When the main engines ignited, everything shook like an earthquake. When the rocket boosters ignited, it gave me a massive kick in the back. The twin boosters shook us continuously as we accelerated at 2.5 Gs.
Thank you for your answer.
Now, let me ask you how the ISS is made.
Interesting. The first rudimentary station was created in 1969 by the linking of 2 Russian Soyuz vehicles in space, followed by other stations and developments in space technology until construction began on the ISS in 1998, aided by the first reusable spacecraft ever developed, the American shuttles.
Wow, that was very interesting. Now, how do you keep yourself fit in space?
To minimize the psychological effects of microgravity, NASA has equipped the ISS with some fancy fitness equipment. There is a space treadmill named Colbert, Sevis, a stationary bike, and IRED, a device that simulates weightlifting.
That was very informative. Now, how water and oxygen is made in space?
For oxygen, the astronaut brings oxygen from Earth and they make oxygen by running electricity through water. This is called electrolysis. The air and water on the space station all originally came from Earth. Up to 90% of the water on the International Space Station is recycled. The water astronauts drink is recycled from their urine, sweat, and exhaled breath collected as condensation on the space station's walls.
Thank you for your answer. Now, let me ask you, how does the ISS fall to Earth?
Very interesting. The ISS doesn't fall to Earth because it is moving forward at exactly the right speed that when combined with the rate it is falling due to gravity produces a curved path that matches the curvature of the Earth.
Thanks a lot for your valuable time and for your interesting answers, Mr. Manjunath and Miss Aishwarya.
According to Newton, gravity is a force, but for Einstein, it is a distortion. Let us see what our friends have to tell on this.
Gravitational waves are ripples in space-time caused by some of the most violent and energetic processes in the universe. Massive accelerating objects such as neutron stars or black holes disrupt space-time. These cosmic ripples would travel at the speed of light, carrying with them information about their origins as well as clues to the nature of gravity itself.
The laser
Interferometer Gravitational Wave Observatory LIGO is a large-scale physics experiment and observatory designed to detect cosmic gravitational waves. On September 14, 2015, LIGO physically sensed the undulations in space-time caused by gravitational waves generated by two colliding black holes 1.3 billion light-years away. This image shows the warping of space and time around two colliding black holes observed by LIGO India is a planned advanced gravitational wave observatory to be located in India as a part of Worldwide Network.
In 1916, Albert Einstein suggested that gravitational waves could be a natural outcome of his general theory of relativity, which says that very massive objects distort the fabric of time and space, an effect we perceive as gravity. These gravitational waves are produced by cataclysmic events such as colliding black holes, supernovae, which are massive stars exploding at the end of their lifetimes, and colliding neutron stars. Every massive object that accelerates produces gravitational waves. This includes humans, cars, airplanes, etc. But the masses and accelerations of objects on Earth are far too small to make gravitational waves big enough to detect with our instruments.
Spacetime is any mathematical model which fuses the three dimension of space and the one dimension of time into a single four-dimensional manifold. Detecting and analyzing the information carried by gravitational waves is allowing us to observe the universe in a way never before possible, providing astronomers and other scientists with their first glimpses of impossible-to-see wonders.
Let us learn more about gravity through some facts that we have compiled.
Relative to the Earth's age in billions of years, the Earth's core is 2.5 years younger than its surface. Moon gravity makes Earth's ocean bulge.
Gravity is the force that attracts planets, bodies, and elements towards each other.
Without Einstein's theory, your mobile phone will not be able to tell your location. It is a natural phenomenon that applies to mass and energy.
Gravity can bend light. Gravity can be used for space travel.
Gravity's inverse square law also means the reach of the gravitational attraction is technically infinite.
Gravity travels at speed of light. Earth is round due to gravity.
Weight changes with planet.
Gravity is the weakest force we know, but gravity is powerful enough to hold galaxies together.
The sunlight takes 8 minutes and 20 seconds to reach the Earth. Artificial gravity can be created using centripetal force.
Gravity only attracts.
Gravity governs the motions of planets around the Sun, holds galaxies together, and determines the structure of the universe itself.
Gravity. Such a controversial topic. Now the question does arise whether Sir Isaac Newton was right about gravity. But first, we need to rewind.
In Newton's view, gravity is a force of attraction between two masses. This universal law of gravitation worked pretty well for predicting the motion of planets as well as objects on the Earth, and is still used today, for example, when making the calculations for a rocket launch.
But Newton's view of gravity didn't work for some things. Like Mercury's peculiar orbit around the Sun. Orbits of planets shift over time, but Mercury's orbit shifted faster than Newton predicted.
Einstein agreed with Newton that space had dimension, width, length, and height. Space might be filled with matter or it might not.
But Newton didn't believe that space was affected by the objects in it. Einstein did. he theorized that a mass can prod space plenty. It can warp it, bend it, pull it, or push it.
Gravity was just a natural outcome of mass's existence in space. Einstein's theory was shown to be correct about Mercury's specular orbit.
But Einstein's theory has faced a lot of controversy, as the quantum field theory doesn't agree with it. And the general theory of relativity does not work near black holes and other bodies which have a huge gravitational field.
His theory was shown to be correct in places with weak gravity. Einstein's theory talked about the working of gravity, which are still being tested today, but has shown to be sufficiently correct.
Now we can end this right here, telling that these two were geniuses of their time who changed our view on gravity.
Gravity is still a mystery, though. We might never discover anything new about gravity, or we might discover something new about it that will change our view on it forever. But either way, gravity will always and forever remain a mystery.
We have learned a lot about gravity from our project day. Isn't it, Nirmalya?
Yes, of course. It was a great learning indeed. Thank you.